Welcome to the Internet Report, where we discussed last week on the Internet. Outages, route security incidents, and headlines from telcos, the public clouds, and more. Joining me to talk about what went down last week is my co-host, Archana and I.
Hey, everybody.
And our guest, who we're really excited to have on, Martin Levy.
Nice to meet you.
Martin is Distinguished Engineer at Cloudflare. He joined Cloudflare about 6 years ago, focusing on expanding Cloudflare's global network footprint. He's now highly focused on BGP route security, and he's a longtime advocate for IPv6 backbone deployment. He's been involved in the Internet Exchange community for some time, and he currently sits on the board of LoanApp. So Martin, welcome again. So Martin, given your work advocating for BGP route security, specifically RPKI, it's very relevant that you're on the show today because a couple of weeks back, we had a major route security incident with Rostelecom hijacking a huge number of routes, including routes to Cloudflare services. So that was a kind of something that we had covered on the show. And what's interesting about that is that there is really quite a number of factors that seem to have been in place. In this particular recent incident, there was, it appeared based on the nature of the route leak and the fact that it was a very specific /21 announcement that it was due to a misconfigured BGP optimizer, which was the same cause for a really massive hijacking last year by DQE, of which Cloudflare was also involved. So optimizer, but also what's really surprising is that some major ISPs did not filter out that announcement and propagate it onto their peers. And that's what seemed to really cause this cascading impact in terms of internet disruption.
Yes, it seems to be a sort of a repeat pattern with a different geography. But the part you mentioned that's absolutely key to find out what's going on here is the /21 route. The route from Cloudflare, if we focus just on Cloudflare, is a /20, and we don't announce a 21. The 21 is created somewhere. In the DQE event last year, it was created by a route optimizer and took a while to get basically turned off and have the routes disappear. The Rostelecom one seems to be a lot quicker.
Right.
It's also a /21, and therefore one can assume the same has happened. But in both cases, whether it be one upstream transit or many peers, you have a route that propagates fairly efficiently and causes the damage. Right. Many backbones were affected. The route optimizers seem to generate sometimes tens of thousands of routes that don't exist at the beginning of the, in sort of the stable, correct internet mode.
Right.
And because of that, and because of the distance that that route can travel, you get some measure of the damage that it causes.
Yeah, for sure. I mean, this was in the recent one, it only lasted for a few minutes, and in that short period of time, it was accepted by level 3 and Hurricane Electric. It was propagated to their peers. Traffic started flowing towards Rostelecom and then was dropped at their network edge because there wasn't anything to send it to internally. And all of this happened within just a few minutes before Rostelecom quickly corrected and revoked the announcements. So, this is kind of speaks to just, how interconnected the internet is. And, any kind of event like this can have a pretty broad impact across many different service providers and users. And so, the incident a couple of weeks ago, and then, or at the beginning of the month, plus DQE, Rostelecom also did something very similar a few years ago. So Cloudflare has kind of had to weather a lot of, these issues, which is kind of why you guys have more recently, not recently, I guess for a few years now, been very vocal in your kind of putting out the need for increased route security, because it's not just things like the BGP optimizer or misconfiguration. It really comes down to kind of security hygiene between service providers and the need to route or filter out illegitimate announcements. So, one of the things that you guys have done recently, and again, you guys have been writing about this for a long time, not only, the danger of optimizers, but also the need to adopt RPKI, which is just one mechanism, but it's a step in the right direction for route security. And more recently, you guys announced, this was just a few weeks ago, a tool called Is BGP Safe Yet? And it basically allows users to check on their whether or not their ISP has adopted RPKI.
Yeah, we did this announcement on the 17th of April. So, nearly 2 weeks ago now. Mm-hmm. And the tool is built upon a couple of different capabilities. One is that all of Cloudflare's routes are RPKI signed. In other words, the origin is has an assertion with inside RPKI, has a rower, which is what you use. It specifies the particular route and the particular AS number. And we then have one route that we announce globally that explicitly is incorrectly signed, or signed with AS0 in this case, which means that this route is invalid and should not be propagated. We announce that route onto every internet exchange, every transit, every partner POP that we have. And that route, in fact, now has a website on it. And that website can be measured in the Is BGP Safe Yet website. Therefore, we can say, you can get to us through a valid route, and you can also get to us through an invalid route. And the moment that we see the invalid route responding, we know that that ISP, and therefore also its subsequent transit providers, are in fact actually failing to do RPKI. So this is an active website. It gets updated. It gets a large amount of tests. But the graph on your screen to the left, which shows the amount of RPKI signed routes in the world, took a jump, and it took a jump higher as of the 17th. People responded to seeing this and responded to the tweets that were created that said that their provider was RPKI compliant or not RPKI compliant. And clearly, this has been taken to heart, and the line has changed. The graph has changed since that date. We are seeing more rowers being created on a day-to-day basis by the community, by providers. This is not work that Cloudflare does. This is work that other networks anywhere in the globe saw a large jump in the Asia Pacific area, for example.
Right.
So cause and effect in our mind is that this has woken people up. This is not the only thing that's done that. The RPKI world and the BGP world has had various deploy-a-thons, like a hackathon, but more about the practical deployment. This has been done successfully in the Asia Pacific region, in the European region, and it generates an uptick in the quality, the signing of routes, and therefore the ability for internet exchanges or for backbones to do their filtering. Right. And so hopefully this graph continues with an upward trend. And although we do still have a long way to go, which I'm sure we can talk about, at least after the 17th, I think that Cloudflare has helped in some way.
Right. So it does seem like, public shaming does actually work. I mean, the getting the consumers, the users involved, because, RPKI, to your point, this has been something that has been an effort within the community. And I think a lot of kind of internet users more broadly aren't aware of this and don't know anything about it. And I think the work that you guys have been doing to kind of get many internet users who, are in fact maybe more impacted empowered and kind of aware of this kind of stuff to activate and to, to hold their ISPs accountable. And that seems to have kind of moved the graph here as we see it. So that's good. And it's important too, because it's not just a question of, Cloudflare or other application or service providers, like web service providers, securing their prefixes or their routes through ROAs. The ISPs must participate in this. It's sort of a takes two to tango. If you do it, if you're, if you're securing your routes, that doesn't matter if the ISPs are effectively ignoring RPKI. So it's got to be a collective effort. It has to be something where everyone agrees that they're going to play by the same kind of security measures. And so this is nice to see that this is on the uptick.
There's enough software out in both the open source environment and others to make deploying RPKI filtering a practical thing for most backbones.
Yep.
And as we have seen with the likes of an AT&T or Telia and others, and we recently blogged with our list, plus the website literally states this because it's tested. We are seeing large backbones that are now doing filtering both at the backbone level, at peer level, and at customer level. And this is pretty fundamental to keep the internet going. The consumer may not notice this except for just, oh, the internet isn't working very well for certain sites at the moment, and then that fixes itself. However, of course, one needs to realize that BGP is underlying all of the geography of where routes and where IP packets go, and therefore the security of the underlying infrastructure is fundamental and needs to be protected. And as the internet has grown, as the number of operators have grown, this is not the little ARPANET that was developed 40 years ago. Right. This is real.
Yeah. Martin, a couple of follow-up questions on what you said is this announcement or this tool is kind of, created that uptick in the number of ROAs being signed. And Angelique, you mentioned that ISPs have to work together to get this done. So what has traditionally been kind of the hindrance for ISPs to, go this route? Like you mentioned AT&T being one of the early adopters to go this route, but we know others haven't. That's one part of the question. The second is, if all the ISPs, over the next year to adopt this mechanism and all routes are signed, is BGP truly safe then?
Right. Great two questions. So the first one, adoption of any technology is hard. People have they have operational issues as to why they cannot just put the latest and greatest out there. The larger you are, the harder it is. You have a lot of other priorities. You have freezes for management reasons. At the moment, we know that certain backbones have got freezes on just because we're dealing with a pandemic and people are not able to work at 100% within those backbones. But it's also a reality that specs RFCs can come out of the IETF and they can take a while before they get into software, before they get to the point of being able to be used.
Right.
So it's natural that things take time. Small networks can implement very quickly, can learn, and we can definitely find certain operational issues. The RPKI environment has required the regional internet registries, the 5 regional internet registries, to develop software and to deploy and to train their users. And that has now been happening. And of course, at the end point, we deal with an internet that is a collection of a very large number of internet routers from predominantly a few companies, very few companies, a handful of companies, but there are others. So we are definitely seeing some hardware out there that is just not capable, not ready yet to run RPKI. That's normally the case in small providers. The cool part is at the big end, at this baker's dozen plus of tier one backbones, you're talking about real backbones with real hardware, with massive support contracts, and a need for various reasons. RPKI is not one of them, but for many other reasons, to keep up with the latest hardware and the latest software. So the excuse, and calling people out for this one, the excuses are becoming few and far between as to why those backbones are not doing RPKI filtering. There's another class here, internet exchanges, which have actually been a lot more responsive in this area. The internet exchanges have built really good software for their route servers, and that community talks to each other, has been upgrading. So internet exchanges are actually fairly far down the road in regards to being able to do drop-in valids for RPKI and provide localized route security in there. The second question involved sort of, when will we get to the end? When, it's essentially like, well, when will we all be secure? And the answer is, sorry, we actually have got a long way to go. And that's not the end of the world, but we have a long way to go. And so for that, I think that we should realize that take the most important networks, work outwards from the core, if one can believe that there's a true absolute core of the internet, and to look at education and deployment of modern day security capabilities, because this is the internet now. And by the way, during a pandemic, even more importantly, the internet absolutely has to perform. So we can't afford these route leak environments. This is not a toy network. It's not a research network. And so, I mean, just to plug, if I may, I mean, Cloudflare put open source software out in this space. Other companies have as well, whether it be the code out of Ripe or NLNet Labs. You'll see other code and deployments out of major providers of hardware. All of this is making it easier and easier for networks to sort of, go down this route.
Yeah, for sure. And even if just the tier ones were to adopt, it would have a massive impact, to your point. And they're
the ones that get the regular, note saying, hey, how you doing? And by the way, last week would have been fine, but not in a year's time. That type of timeline does not work. Access networks, by the way, have just as much need for this as do cloud providers. And if I give another plug, the Internet Society's Manners program has now sort of got three areas: core backbones, internet exchanges, and now cloud providers. All of those need to be up to speed and fully RPKI compliant.
Yeah, absolutely. And for those who own prefixes, securing their IPv spaces is becoming much easier. As you said, there's a lot of tools out there. It's not as scary as it appears. Yes, there's some idiosyncrasies in terms of how you configure your ROAs, but it can be done. And you can also, validate once you've deployed that your sites are reachable in the way that you expect them to be. So there isn't a whole lot of excuses to not go down the path of adopting. So
the validation stage is an important one.
Yeah.
You
Absolutely.
can run RPKI in a soft mode and at least understand that you have everything ready,
right?
And that you have this ability to, to see the routes that you would drop, and then you get to drop.
Yep.
RPKI is a rather special situation. It's very important to understand that the RPKI data that, let's say, Cloudflare filters on its network is in fact identical to the filter set that an AT&T or other backbones filter with.
Mm-hmm.
And so if we see something wrong, let's say something that is going to get dropped that shouldn't be, or the other way around, we can contact that player, or somebody else can contact that player, but it's actually a common issue. So coming in now into an RPKI capable backbone is a much easier task than it was, let's say, 2 years ago. Nowadays, there are so many people that are filtering. If somebody actually has a mistake within, say, their RPKI data set, it will be seen by many and be hopefully fixed by many well before it becomes an issue for any particular network. So being late to the game is bad, but you can stand on other giants and simply go, right, well, it works for everybody else. Let me do it for myself.
Right, right. Yeah, absolutely. So on that, I mean, we can talk on RPKI and route security all day, but there was a really interesting sort of event that happened last week, kind of a notable outage of the week, and that was Virgin Media in the UK. The broadband provider had a pretty significant outage that affected a lot of users, or a lot of chatter on social media. And the nature of this outage was really unusual as well. We saw it on a number of ways, not only on Virgin Media's infrastructure, but more broadly on another network that's owned by Liberty Global, so UPC. So Archana, you going to walk through that?
Yeah, I can work through that. So we caught this in Thousand Eyes, and then we'll look at some trends that, Cloudflare also saw, and the similarity in those patterns. But what we saw around happened on Monday last week around 9:15 Pacific, around, I guess, 5 p.m. in EMEA and UK. We started seeing LGI is Liberty Global, and UPC is a part of Liberty Global, and so is Virgin Media. And what we see here from an outage perspective is this, interesting pattern where it repeats itself. So it lasts for about 15 minutes, but then it repeats itself every hour for the first 3 hours, takes a break for a little bit here, but then shows up again. And if you double click on it, it's multiple locations, not just within London, but we saw Amsterdam get impacted too. But
and
again,
Ireland as well, yeah.
Yep, yeah, Ireland as well. UPC is heavy in Ireland, so definitely there. But what was interesting is this trend, right? Like it lasted for a few hours overall, but time it lasted for was very short, but then it kept repeating itself, which is very similar to that pattern that we also saw from the Cloudflare graph there. So
yeah, it was interesting because I know that on your guys' side, you had seen during this incident that traffic destined for prefixes owned by ASN 5089, which is Virgin Media, and that's what's serving like kind of the consumer users are connecting to, basically dropped. And that coincided with what we were seeing, which was in this infrastructure that's managed by Liberty Global, as well as Virgin Media. There was this outage event occurring around the time. So started around 5:17 p.m. And then again, we see, both of us saw this kind of hourly, this incident, short-lived, but just kept recurring, which suggests that it could have been related to some automation issue. So why don't you walk us through kind of what we're looking at up top, Martin?
Yes. Cloudflare delivers traffic to nearly every AS in the world, and definitely just about every IP address in the world. So this is sort of a collective graph of all the traffic that we're delivering to Virgin Media in the UK. And the graph is normally a nice smooth graph. You can tell when people go to sleep. You can tell when people are awake, as per you would expect. By the way, our graph is all in UTC time, because we're sort of a global company. We have to pick something, and so it's not even UK time. It's UTC. So we saw this drop in traffic. We saw the inability to deliver pages to Virgin Media, and we also saw UPC as well. If I had a different graph published, it would show the two of them in lockstep. And those graphs are about 15 minutes past the hour, and 3 repeats, it misses an hour. 1 repeat, it misses an hour. 2 repeats, and then finally, very early in the morning, you can assume that the engineers finally get to go home, or get to continue being at home and fix their fix their issues. So automation, yes, by the way, not RPKI based
Right.
in any way. I mean, this is
Totally
that's
unrelated.
sort of,
Yeah.
we could definitely change subjects here.
Yeah.
But basically, you know, we haven't seen them announce what actually happened. The fact that it happened over 2 different ASs that are essentially part of the same company,
Yep.
kind of leads the way to automation being the issue. Interestingly, you saw it at interfaces, we just saw it as the end user, but they both sum up to the same thing. Cloud through infrastructure to the end user, and the end user has got restricted access to the internet. Obviously, this graph is much smoother if you look at different operators. So we can sort of clearly see it's affecting, in this case, a couple of ASs and nothing else. This is a graph from a tweet pretty much the next day when we knew that things had quietened down.
Right.
You know, we could see that 12 plus hours of
we saw the last little kind of outage blip happen like around 1 a.m., 2 a.m. or so. The bottom graph, you know, just I guess because we're being somewhat California centric, this is in Pacific time. Could have changed this to UTC. That might have been a little bit less confusing, but nevertheless, you still see that pattern. What was also interesting that you had kind of brought up was a blog article by Ben Cartwright Cox, who he talked a lot about these same things. He again noticed this this peculiar pattern, not only in your traffic stats, but also in some probing that he had done. But he also saw that as this outage unfolded, as traffic would or as the network basically came back online, that we would see these huge spikes in users basically testing their bandwidth. And then that could also have, you know, an impact on network congestion as well. So it's sort of like there was an issue with the network, and then users kind of would collectively all at once respond in a similar way, and that could create congestion issues. And then, you know, you could get into this vicious cycle at some point with users kind of just continuously testing, but the testing itself actually causing an issue, which was an interesting angle to kind of bring in terms of how human nature can also influence how the network is performing.
Yeah, it was a great observation on the part of Ben. And it makes perfect sense. Users have one tool, speed test, they know it, or its equivalent. And they instinctively just go to that test. But what's interesting is that if you assume that this outage was absolute, in other words, it wasn't about congestion.
Right.
It was about an actual outage, a lack of the ability to move bits between 2 places. This is the wrong test.
Yep.
And users don't have, and by the way, network engineers are only slightly better in this case. Network engineers, you know, heavily use traceroute, ping, etc. But the reality is that they still sort of care about absolute throughput. And an event like this, in fact, actually, that's not the test you want.
Right.
You really want to understand what's my breadth of connectivity. Can I get successfully, which we don't know, successfully to the internals of the network versus the externals of the network. And so I'm not going to take on the task of educating end users. That's far too complicated.
Right. A speed test, but to your point, I mean, speed test is a pretty, you know, it's sort of like bringing a hatchet, you know, when you really just need a scalpel. You know, just a simple ping test to some, you know, external destination probably would have done the trick versus, you know, a bandwidth check. So
sounds like a good feature request for the speed test app.
Yeah, I mean, you know, to your point, maybe this just you know, the users need to understand that they have a variety of tools at their disposal. And this is kind of going back to the work that was done around RPKI, which is this, you know, this very, you know, a capability or a mechanism that has really been something kind of the provenance of like the internet community and not really users at large. But we apparently, you know, consumers can be educated, and you know,
users can absolutely be educated, and the Easiest example to use is the green lock in the top of your browser.
Yep.
Foibles aside,
right.
The fact that users now understand a green lock when they're going to their bank is an important thing to recognize.
Yep.
So I know that's a simple one, but let's hold out hope for end users. But anyway, Ben's blog is, which I hope you add the link to.
Yeah, absolutely.
Has some great conjecture in it, and I think is a wonderful thesis on things that happen. He's got some obvious some real measurements in there as well. So
yeah,
it's worthy of discussion.
Absolutely. I mean, we've definitely seen the influence of users on the internet just over the last few months, and kind of influencing how they're using the network, whether that's using more video conferencing apps, or the fact that they might be consuming more upstream bandwidth versus downstream. And that's been somewhat of a difference, or that's been different over the last month or so. For sure, the user has to be factored in whenever you talk about internet performance as well. Which brings us to kind of our outage roll-up from last week, just taking a look at some of the outages that we picked up. The internet is a pretty broad place, but some of the ones that we saw last week. So there was around 282 outages, which is a reduction from the previous week. And 98 of those were in the US. So that's overall, that's including ISPs, public cloud providers, video conferencing app networks, as well as DNS, CDN networks. And then on the top right, we see the ISP portion of that, which is, it's a big bucket. Most of the outages we saw were in ISP networks, so 236, which is down from the previous week of 250. And then cloud service providers, generally speaking, we don't see a lot of issues in their networks, and we really only saw, a dozen globally and just one actually in the US. And that's pretty significantly down from the previous week, where we saw about 26, which is what we typically see. We haven't seen any unusual spikes over the recent period with public cloud providers. So overall, looking pretty good. Just with the exception of this little, a bad day for Virgin Media last week, things are looking good overall. So with that, any last questions, comments, Archana?
No, I think I'm good. Martin, thanks again for being a part of the show. It was a lot.
Great having you.
Yeah, great information there. As always, guys, leave us a review, follow us on any of those channels that you see there. We're available in most of the podcasts out there. And again, if you're interested in our newest t-shirt, which is working safely from home, email internetreport@thousandeyes.com with your address and size, and we'll send that over to you. And again,
I need the V6 version of that t-shirt, by the way. Great t-shirt, but I need the V6 version. Even though I am wearing a V4 address t-shirt today, but I have an exception on that one. I'm allowed to do that. I know that. Anyway, it's been great, guys. Absolutely, absolutely superb. And hopefully the internet gets better next week and the week after.
Absolutely, and join us again.
All right. Thank you very much.
Thanks, everyone.
Bye.
Bye.